In this video, I go over geometric sequences. A geometric sequence is similar to an exponential function, but for geometric sequences, the domain is restricted to natural numbers. One formula is the general form for any term in the geometric sequence, where a1 is the first term and r is the common ratio. You can find the common ratio by taking any term in the sequence a sub n and dividing it by the previous term a sub n minus 1. The sum formula can be used to find the sum for a finite number of terms in a geometric sequence. Let's look at an example. If we have a sub 3 is equal to 80 and a sub 6 is equal to 5,120, we're going to find s sub 10, or the sum of the first 10 terms in the sequence. If we're given that this refers to a geometric sequence, we can use the formula a sub n is equal to a sub 1 times r to the n minus 1. And I'll start by using each term that we do know and plugging it into this formula. So we have a sub 3 equals a sub 1 to the r squared, which equals 80. And that's our first equation. And then we'll do the same thing for the other term, a sub 6. Which equals a sub 1 to the r raised to the power of 5, and that equals 5,120. Now we have a system of equations. For this problem, I'm going to use substitution to solve it. I'll start by isolating a sub 1 in the first equation, which gives me a sub 1 is equal to 80 over r squared. And then I'm going to take this expression for a1 and plug it into the second equation. Simplifying the r's gives me 80r cubed is equal to 5,120. Dividing both sides by 80 gives me r cubed is equal to 64. And then the last step is to take the cube root of both sides, which gives me r is equal to 4. And now I'm going to plug this value to find a sub 1, which is 5. Now that we have found the common ratio r and the initial term a sub 1, we can plug these values into the sum formula to find the sum of the first 10 terms in this geometric sequence. So s sub 10 is equal to 5 times 1 minus 4 to the 10th over 1 minus 4. And once we evaluate this, we end up with 1,747,625.